Right, so you're looking at the theory questions, and I will assume that we know nothing. Even you guys, I would want you to make that assumption. We assume that we know nothing, and we have a look at the questions that came last semester. So here we are. So question number 1, how fast data is processed and accessed is represented by which of the following V's of big data? So ladies and gentlemen, if you remember from high school, velocity has got everything to do with speed. So whenever we talk of speed, how fast data can be accessed, processed, we always talk about what here? Speed, which is what here? Which is velocity. Now, there is another term that you guys are not supposed to confuse at all. This concept of veracity, it's an English name, veracity, meaning what here? Of high integrity, accurate, reliable data. So veracity is something that I would want you guys to know. Whenever you see veracity, just like if you get a lady called Felicity, quite similar to veracity, a person of high, so the data must be of high integrity. It has to be what here? Somebody high quality, reliable, truthfulness, something we can trust. So of course you have the answers you'll be able to go through, like virality. There is nothing like that among us the 5 V's. Now, if you allow me, I'll go to question number 2. Data modeling is a process that helps one to understand the structures, form, and relationships of information. It requires to first think of the model, then identify the model details, and then how the model will be implemented. Which of the following is the correct name of data model implementation? Ladies and gentlemen, remember in our normal class, we spoke about how we model data, how we come up with a program. So of course, at first, it has to be at concepts level. So in this case here, we sit, for example, with the owners of the processes. These guys here would want us to come up with a program, but they may not even be very sure of exactly what they want to do, us to do. But of course, they have the concept. Just like, for example, when you want to, or rather a client of yours, if you're an architect, wants you to draw a house. So when they come to you, I mean, these guys, what they have is just the concept. So you as the architect, you'll be the one in this case to put this concept on paper. So the very first thing, ladies and gentlemen, whenever we talk of data modeling, is to do it conceptually. Sit down with these clients here, discuss. And then now, ladies and gentlemen, from there, now we have the logistics here, the logical, so thoughts. So now your thoughts are being put down on paper. So it is in this logistics, ladies and gentlemen, logical flow where we talk of the coding thing. And then now, ladies and gentlemen, lastly, now we have the physical. Now the physical is when you are implementing. You're implementing this. You're building the house. You're implementing now. This idea has become a design. Now the design in this case is being implemented. So whenever you talk of how the model will be implemented, which of the following is the correct name of data model implementation? You can't implement at the idea stage. It can only be implemented at this physical stage. So C is the correct answer. So first of all, are we together up to there? Are we together? Great. Now I look at question number 3. The following activities are included in the CRISP, cross-industry standard process for data mining. So we have data preparation, data understanding, data deployment, business understanding, data evaluation, data modeling. Which of the following is the proper sequence of these activities? Is there somebody who can tell us what the sequence here is? What should we first of all get ourselves into when we talk of cross-industry standard process for data mining? Extraction of data for modeling purposes. Yeah, the first thing is to understand the business. So you come to RCM, before even understanding the data, you must understand the business. So business understanding, yes, business understanding. After you have understood the business, now that's when you come to the next stage, which is now data understanding, which is data understanding. So we start with number 4, business understanding, and then we go to data what here, somebody, data understanding. After we understand the data, what do we do? After understanding data, what do we do? Of course, in this case here, we shall start now the extraction and of course, preparation of the data, cleaning the data. So after that, that's number 1. Now straight away, you shall go to what here stage here? Data modeling. Because now you have got clean data. Now you can mention there, for example, want regression between A and B, because again, you can't just do one model. You do many models here. Out of these many models, you'll be able to evaluate them. You do data evaluation. Once in this case, you say this is the better now, this is the very best model, you go ahead and do what here? You deploy it. Data deployment, very, very important. Ladies and gentlemen, in this case, of course, the moment you capture like 3 of them, you'll easily be able to see, the pattern. Like now, D is correct. First of all, you start with understanding the business. We understand the data. We start in this case, this concept of extracting data, cleaning it, like that's called data preparation. After that, now we come up with a model. After coming up with a model, we do evaluations between the many models. Of course, we can't only do one model. From there, now we stick with one. We go with one after the evaluations. Then straight out, we should be able to do what you have to deploy. Deploy is to use. All right. Now, ladies and gentlemen, here we have a very interesting question here. We are told here the process for data mining. Which of the following is not an activity in the modeling stage in the CRISP model? Is not an activity in modeling stage, not an activity in a modeling stage. So in a modeling stage, ladies and gentlemen, of course, we shall be building. In a modeling stage, especially those algorithms, many, we shall be making selections. We shall be doing, in this case here, the design. The design. What we don't do, ladies and gentlemen, here is the evaluation, because evaluation is a different step, is a different stage here. In terms of a CRISP model, ladies and gentlemen, you can see here modeling and the evaluation are 2 different steps. There are 2 different steps. So for a model, ladies and gentlemen, of course, we must build. Please listen and listen to me very well. We must build like the prototypes, the dummy models. You must do those dummy models, like many of them. Select, in this case here, the very best. You have, in this case, your designs. The designs have to be there even before you start doing what your selection. So you design first, you select, and then you build the model. Now, when you talk of evaluation, which is now part D, then automatically you're going to another different step under the CRISP model. You're going to a different step under the CRISP model. Now, ladies and gentlemen, from there we go to the next one for data visualizations. When you are doing those graphs, ladies and gentlemen, to visualize, of course, we are now moving beyond numbers. We want to draw, in this case here, our data presented in the form of bar charts, etc. For data visualization, a bar chart will be classified as a what? Is it a distribution tool? Remember distribution, the frequency, distribution is like ugali kamluya, right? Like a normal curve, like a histogram. I'm a frequency curve in your distribution. Then we have relationships. We have, in this case here, comparison. Composition, ladies and gentlemen, of course, composition. Here we are looking at components. Like the pie chart is able to bring out those components very well. The pie chart. All right. Comparison, we have, in this case here, comparing those bars. All right. So you're right. So in this case, ladies and gentlemen, the correct answer is comparison. It's important we read the others. Distribution. Distribution visualizations that fall under the distribution category are used to represent the frequency, the spread or frequency of data values within a single database set. Histograms and box plots are examples of distribution visualizations. So if I were you tonight, I would go and Google these box plots. Even search for them on YouTube, isn't it? How do they look like? Because I know all of us know how histograms look like. But just try to understand how the box plot looks like. Relationship visualizations are designed to illustrate the connection or correlation between two or more variables. I mean, I can do a scatter plot, a scatter graph, and see how the points are scattered there. Once I see how those points are scattered there, then I'll be able to deduce whether I have, in this case here, for example, what we call a direct relationship, a positive relationship between X and Y. I can see how the points are being scattered. I can see if they're negatively related like that, right? Scatter plots, line charts, etc. They help us visualize how variables are related, And then we have comparison. So comparison visualizations, as mentioned in the question, are used to compare different categories of data points. Bar charts, along with pie charts, stacked bar charts, and the column charts are classic examples of comparison visualizations. They make it easy to compare values or categories and identify trends, differences, or in this case, similarities. So like a pie chart. If you're looking at, for example, BDA students vis-a-vis the entire RCM population, you'll be able to compare between even various courses. See, this course is an Ochugunu, has got nothing. This one is a big course. Composition visualizations focus on illustrating the components or parts that make up a whole, like a pie chart, a part that is making up a whole. Examples include pie charts, etc. So, of course, the correct answer here is comparison. Bar charts are for comparison. Those bars, ladies and gentlemen, we are able to see, you can put them side by side and see which one is bigger. So, of course, this is what we call like a stacked bar chart. Like now here, you can easily see. Let me see, like we have here, I have the codes. Like this color here, which is quite close to yellow, I'm not very sure, is for apples. So you can see the comparisons here. I mean, apples, oranges, and bananas in this year 2010. Apples were doing very well. So I can see with the time, you can see like now from here, apples are moving down. Consumption is moving down. Bananas are gaining like that. So you can use this stacked bar chart. Stacked means putting on top of each other. You stack like that. Yeah, for purpose of what here? Comparison. You can use a pie chart for purpose of doing what here? Comparing items. Purpose of comparing items like that. All right. Question number 6. So question number 6, a data analyst would like to present data in the form of a distribution. He will likely use all the following, except the distribution. Of course, very best we capture it using what here? A histogram. A histogram. Histogram is the number 1 form of visualization for distributions, where you draw your frequency charts, and then of course you're able to do what here to see how the distribution of the data points are. Do we have in this case some points which are really clustered around the mean? If many of them are clustered around the mean, then this may end up being a normal distribution. A normal distribution. So I can see already guys have given me answers. Yeah, you can't use in this case here pie chart to show the distribution of values. If the worst gets the worst, I can use a line chart, and of course, line chart, I'm using those scattered points, and then I join those lines like that. I can as well use just scatter graph to see how these points are distributed around some metric like the mean, I'm so happy, ladies and gentlemen, you guys are doing what here? You guys are following. And then, ladies and gentlemen, we have question number 7. Question number 7, data ethics are the norms of behavior. Are the norms of behavior that promote appropriate judgments and accountability when acquiring, managing, or using data. with the goals of protecting civil liberties, minimizing risks to individuals and society, and maximizing the public good. All the following promote data ethics, except which one? Is there someone who knows the answer? Yeah, A, you're right. That's why you'll get even some subjects here talking about what here, law vis-a-vis what here, ethics. Remember, under law, there's an obligation, right? Under law, the laws are clearly spelled. But when you talk of, ladies and gentlemen, this thing called ethos or ethics, there are a lot of judgments. I mean, some ethos may be well within, or rather, they may be good. But in some operations, in some geographical areas, in this case, they could be unlawful, right? So for example, like if you're in America and maybe you've conceived and there is threat to your life as a mother, I mean, there they will really just go the abortion way, all right? Ladies and gentlemen, please let me simplify this. When you talk of data ethics, look at this. Are the norms normal norms of behavior that promote appropriate judgments and what here accountability promotes appropriate judgments and accountability. You see, judgments now cannot be a law, right? So appropriate judgments. So meaning that, ladies and gentlemen, at the end of the day, ethics, of course, we are looking at it from your own judgment, but at the end of the day, you're looking at being fair to everybody, right? So like now when we're talking of data mining, you've mined in this case a lot of data of people, right? It could be within the law. For example, when you go to a court of law, you can even say that this is how I got this information. But now the question is it ethical? Is it ethical? So all the following promote data ethics except complying with the law, promoting transparency. Of course, in this case here, this is what here is ethical. Respecting privacy and confidentiality, we do that, then that is ethical. Ethics is all about what here? Fairness. So contribution, complying with the law is essential for ensuring that data practices are aligned with legal requirements related to data protection, privacy, and security. It contributes to avoiding legal penalties and liabilities associated with non-compliance. Validity, complying with the law is a valid and necessary aspect of data ethics. It provides a legal framework that sets the minimum standards for responsible data handling. However, it is important to know that ethical considerations can go beyond the legal requirements to ensure more comprehensive protection of individuals' rights and what here, privacy. The thing is, when we talk of ethics, don't go hiding behind the law. And for sure you are infringing on other people's what here, rights. All right. So for example, if you come and tell us, I have this person here, kid, I've paid this kid here, and this person has been able to help me to, if it's child labor, it's child labor. All right. At times, some unethical practices could also be illegal, but it's not always that ethical practices and ethical practices have to be illegal. No, there is a separation. There is a separation between what we call ethics and what here and law. Actually, in most cases, they tend to fight. They tend to fight. But at the end of the day, if it's ethical, we are trying to promote what we call transparency. So when I'm collecting this data from this person, I would want to tell him from the word go, how am I going to use this data? That's key. It's about fairness. If I'm going to use this data and of course we gain as a company, then it can only be honorable for you to also reward the other party. Because, ladies and gentlemen, data integrity is all about what here? Fairness. It's all about fairness. All right. And then, of course, the concept of respecting privacy and confidentiality. What we discuss, of course, you should not be able to disclose the same to third parties without doing what here, without mentioning it to me. All right. So once we do like all these questions for all the sittings, then everything will be okay. Which of the following is not a concept of data integrity? Data integrity means whatever the data is current. Don't use very, very old data, and then you want to tell us that this data portrays integrity. Ladies and gentlemen, remember, integrity is all about reliability. Integrity is all about straightforward. All right? So in this case here, if this data is to be reliable, it has to be what here? It has to be current. If it is to be relied upon for decision making, it has to be what here? Accurate. It must be valid. So which of the following is not a concept of data integrity? Of course, the answer here is A now. Data availability. Data availability is a key concept of data integrity. It refers to the assurance that data is accessible and ready for use when it's needed. Ensuring data availability is vital to maintaining data integrity because it ensures that data is accessible, reliable, and can be used for its intended purposes. Okay, we shall come back to this. Let's go to part B. We see data currency. Data currency, also known as data freshness, is another important aspect of data integrity. It focuses on the timeliness and relevance of data. Current and up-to-date data is crucial for maintaining data integrity because outdated or stale data can lead to incorrect decisions or analysis. Data accuracy is a fundamental concept of data integrity. It relates to the correctness and the precision of data. Accurate data is free from errors or discrepancies, and it is a critical component of what here? Data integrity. When we talk of data validity, ladies and gentlemen, is another essential concept within data integrity. Valid. It refers to the adherence of data to defined rules or standards. Valid data conforms to specific criteria and ensures that data is used in a consistent and reliable manner. Data availability is a concept of data integrity because it's crucial for ensuring that data is reliable and trustworthy. Therefore, amongst the provider options, there isn't one that is not a concept of data integrity. All of them, A, B, C, D, are related to data integrity. I think this guy must have gotten this materials from somewhere. When we talk of, ladies and gentlemen, data integrity, if you've covered this, we are looking at this. Of course, also data, it has to be available. That's what these guys are trying to tell us. But at the end of the day, ladies and gentlemen, the ones that are very connected to data integrity, we have currency, accuracy, and what here? Validity. This availability features nowhere under data integrity. Features nowhere under data integrity. All right. So in this case here, when you talk of data integrity, if they try to twist the question, we are looking at three things. Data must be current, it must be accurate, it must be well within the confines of whatever standards you have given. It has to be valid. Question number 9. With a high volume of data available for businesses, collecting meaningful data is a big challenge. To enable handling large volumes of data, data collection tools are critical. Which of the following will likely be a data collection software? Excel is for data analysis. Python, we use Python to come up with programs for analysis. Yeah, for analysis. You have a program, in this case, it can enable you even do visualizations. You have a program. R is so big, ladies and gentlemen, for statistical information. So big for statistical information. Then we have Zoho, just like Arrow, all right? These accountancy softwares, ladies and gentlemen, are so nice. Why? Because we normally use what we call an integrator. Once I bring Zoho and, for example, connect it to your company's ERP, I will be able, ladies and gentlemen, in this case here, collect meaningful data. I'll be able to collect data that will be used, for instance, for financial reporting. So if you remember Zoho, we have another one in this case that has come in the market, which is really doing very well. I don't know whether it is pronounced as follows. You must have heard this. Udo. Is it Udo or Odo? I don't know. Very, very popular. All these, ladies and gentlemen, even QuickBooks, even Tally Prime, Tally ERP, Those models are very, very important and can be used in this case here for purposes of what here? Collecting meaningful data. Data that will be used for purpose of what here? For example, financial reporting. Data which will be used for financial reporting. With a high volume of data available for businesses, collecting meaningful data is a big challenge. To enable handling large volumes of data, data collection tools are critical. Which of the following will likely be a data collection software? It can't be Excel. Excel, of course, you'll use Excel here yourself, you're punching in data, right? You can't use Excel in this case here to collect data from other sources here. Python, in this case, you are making yourself a program, right? R is for statistics. If you want R squared, you want coefficient of determination, coefficient of correlation, then you can use R. But Zoho being a financial reporting automated software, once I simply come and take Zoho, put Zoho in this case here together with your ERP, it will not give me CRM information. It can't give me customer relationship management information. It knows what to pick to be able to do a P&L. It knows what to collect to be able to do a balance sheet, a cash flow, etc. All right. It's important that we go through these answers. So we are told, ladies and gentlemen, here that a data collection software is a tool or platform that facilitates the collection of data from various sources. Among the options provided, Excel, Microsoft Excel is primarily a spreadsheet software used for data analysis and manipulation. You can change data the way you wish. Python is a general purpose programming language. While it can be used for various data-related tasks, including data collection through web scraping or API integration, it is not a data collection software in itself. It requires the development of custom scripts or programs for data collection. You must come up with a program. Because, ladies and gentlemen, remember, Python is a coding language. We have R is a programming language, and the environment specifically designed for statistical computing and data analysis. Similar to Python, it can be used for data collection tasks, but it's not inherently a data collection software. And then we have now Zoho. Zoho offers a range of cloud-based software applications, including those for data collection and management. Zoho Forms, for example, is a tool designed for creating online forms and surveys, making it a data collection software. It has a very big thing for monkey surveys. So, but most importantly, ladies and gentlemen, is that this Zoho thing is a financial reporting tool that is very, very practical and used here, of course, for purposes of sniffing, taking financial reporting data from ERP systems. Very, very good. You can integrate it. Question number 10. A data analyst makes the following comments about functions in Excel. To determine the variance of a list of 10 numbers, we use var.population. To determine the standard deviation of 10 numbers, we use var.p here. A1 to 10. And then we have, ladies and gentlemen, to determine the variance of a list of 10 numbers, we use var.what here, .s. Ladies and gentlemen, basically this was a sampling question. If, for example, you have a small sample, of course, in this case here, the variance you will calculate is for the small sample. So it should be var.s. But if your sample is large means more than 30, automatically to be approximating what we call the population. So if the sample is very large, then automatically we shall use what we call var what here? Var p. Now please listen. 10 numbers. 10 numbers, number one, they are less than what here? Less than 30. So this is what we call a small sample. So and if it's a small sample, then number one, I should be able to use what we call var.what here? .s. I should be able to use var.s because it's a small sample. Now listen, there is a disclaimer here. What if, for example, ladies and gentlemen, We are given these 10 things, 10 things. The 10 things you are given, ladies and gentlemen, the 10 things you're given, ladies and gentlemen, are exactly what here? The whole population. They're exactly the whole population. In that case, I will use var P or var S. I mean, we have it's a class of 10 people, and 10, of course, happens to be a small sample. Will I argue out that this is a small sample? Maybe you haven't gotten my question. You have picked 10. And this 10 you have picked, ladies and gentlemen, in this case, ladies and gentlemen, is the entire class. You see, that is your population. That is your population. That is your population. So it depends. In this question, they never told us that this 10 is the population. They only spoke of what here, 10 number. So the best thing to do as a statistician is to assume that 10 is just part of what here, a population. And since it is below 30, since it's below 30, it's a small sample, then I'll use what we call var.s. var.s, not var.what here, dot p, not var.p. All right. Now, ladies and gentlemen, C3 is correct, yes. The following are the various phases of data models. We have physical, logical, conceptual. This one I cannot even take my time here. This is very easy. Just like the house, I've given you a very good example, the correct steps here. One, so it will be conceptual, isn't it? From there we go logical. Logical. From there we go now physical. We go physical. So we are told here data modeling is a process of creating a visual representation of data and its relationships to understand, define, and organize data more effectively. It helps in a database design and development. So you're told here conceptual data model. This is the highest level of abstraction. You know, an abstract is something that when you are writing a thesis, an abstract, basically you are at the very, very initial stages. I mean, you don't know how this particular project will pan out, right? So basically you're trying in this case to give us like a summary, all right? You don't know, for example, when you talk of literature review, right? ETC, I mean, there is very, so you're giving us what we call an abstract. It focuses on understanding the business requirements and the concepts without considering technical implementation details. In the conceptual model, you define entities, their attributes, and the relationships between them. It's like creating a high-level map of what data needs to be stored and how it is related, how it is rated, how it is related, and how it is rated, how it is rated, and how it is rated, without thinking about how it will be implemented. Then now we have the logical data model. Logical data model, ladies and gentlemen, logistics, logic. In this phase, you start refining the conceptual model into a more detailed structure. You define the tables. You have the fields, the data types, and relationships between them. It is still an abstract in the sense that it doesn't consider the specifics of how the data will be physically stored or accessed, but focuses on the structure and relationships. And then now we have the implementation physical data model. This is the most detailed and concrete phase. In the physical model, you define how the data will be implemented in a database system. It includes details such as the indexes, storage mechanisms, data distribution, and constraints. It is the stage where you consider the actual technology and how data will be stored and retrieved efficiently. So it is the stage where you consider the actual technology and how this data will be stored. So are we going to store this data in, if it's video or structured, do we store this thing in AWS, the Amazon cloud services? And how are we going to retrieve this? We must also, in this case here, have a command. We must have, in this case, a security. So that is at the stage of what here? Physical data model. All right. So of course, these, the correctors I've seen there, you guys have mentioned there. So the correct order of the data modeling phases from high-level abstraction to detailed implementation is conceptual, logical, and then physical. This order ensures structured and systematic approach to designing and implementing a database system. Question number 12. Which of the following techniques is least effective in obtaining data for easy storage and analysis? Ladies and gentlemen, I would prefer like this Google Forms, the online questionnaire. Because if it's a Google form, I mean, I will end up getting so much structured data, right? Even these email questionnaires, because I mean, I can close them up. I can have a closed ended questions where in this case here, I just put box the interviewees. So is it A, B, or C? Choose like that. So in this case here, the least effective, of course, will be the interviews. And if I'm to choose between recorded and just the normal oral interviews, these interviews here will be very, very abstract, will be very, very, ladies and gentlemen, in this case here, if least effective. Because I mean, somebody will give you story A to Z, when you get another person Z to A, like that. And at the end of the day, when it comes now to storing that kind of information being given, which is very subjective, it becomes what here very, very hard, very, very hard. Very, very hard. You would rather recorded interviews. You would rather recorded interviews. So the list there is what here is A. Is A. Are we together up to there, ladies and gentlemen? Are we together? Are we together really? All right. All right. But you seem to be knowing these things. You seem to be knowing these things. You seem to be knowing them. I'm so happy. So then what I'll do is just to share with you these handout. And then, of course, we also need to discuss like now moving forward. Of course, I'll also be able to upload this, whatever we discussed on YouTube. When you see it there, you must, subscribe to my channel, right? Now, I would want us to discuss about tomorrow. Are you guys on leave? Are you guys on leave? Are you guys on leave? Mchana, mimi niko leave. Niko leave, ningetaka tu, great. Great, great. Ala, nimeona no moja. So hao wanasema no. What do you think in this case here tunaweza tukafanya class kama, unajua problem zikienda zote jioni zinachokesha sana. Zikienda zote jioni zinachokesha sana. I would rather come ngesema saa 8 moja alafu ingine usiku. Would have really done a lot. Wamekataa.